Good afternoon. Welcome to today's faculty seminar. Normally, Dr. Martin Scanlon, our Associate Dean Research, chairs this seminar series, but unfortunately coincided with the time that he had a class, so he's giving a lab and is not able to be here, and therefore he asked me to step in for him today. So my name is Martin also. I'm one of the three Martins in the faculty. Martin Yachati, I'm the head of animal science. So I will be chairing this seminar today. And before we get started, I would like to say a few words as a way of introduction for Argenis, who's going to speak today, so that we know a little bit about his background. So, Dr. Argenis Rodas-Gonzalez joined our faculty in July 2014 at the level of assistant professor in meat science and food safety, with a primary appointment in the Department of Animal Science, but he does also have a close appointment in food science, which is now the Department of Food and Human Nutritional Sciences. He holds a Doctor of Veterinary Medicine and a master's degree in meat science from the University of Asturias in Venezuela, and a PhD in meat science from Texas Tech University in the United States. Prior to going to graduate school and moving to Canada, Argenis spent 16 years in academia in the university in Venezuela, rising to the rank of associate professor. And following his PhD, he moved to AFC in Lacombe, Alberta, and completed a 2-year postdoctoral position there, our appointment there before he moved here in 2014. In terms of his research career, Dr. Rodas-Gonzalez has been involved in a number of multidisciplinary research projects, working with different groups in Venezuela, United States, and here in Canada. Looking at different aspects with a primary focus of his activities or research activities on applied animal growth, looking at animals that are under grass-fed regimens, evaluation of tropically adapted cattle such as Cebu, Creole, carcass evaluation, carcass grading, palatability studies, and nutrient composition and food safety, and shelf life of meat products. Currently, he is examining rapid discoloration mechanisms in bison meat and the application of novel technologies to control that, which will be the topic for his presentation today. As part of his productivity, Dr. Gonzalez has published 1 book, 6 book chapters, and 48 peer-reviewed journal articles. And he's been an invited speaker at 24 different venues or events in different countries. With that, please join with me in welcoming Dr. Argenis Gonzalez to give his presentation entitled Bison Meat, Cara Matters.
Thank you so much, Dr. Nayotti, for the presentation, for introduce to the audience. Before I start, I need to give, I need a favor. I'm recruiting panelists for my research in bison, so I really appreciate if you can show up tomorrow between 12:30 to 1:30, 2:30 in food science building, so we can do the sensory evaluation. There are some flyers if you want to know more details, but the most important is the $10 gift card. So, okay, bison meat. The colors matter. When we talk about color, usually color is an attribute that drives your purchase decision. It's an indicator for consumer freshness and wholesomeness. Okay, and any deviation of that color, usually we have in mind the color is cherry red. Any deviation of that parameter in your mind you are thinking is the meat is spoiled or is an old animal. But what happened with bison? Bison has the characteristic that is a dark red color when you compare with other species, okay? But the point is not the dark red color. The problem is deteriorates so fast the color. In 2 days, you can have this kind of brown or discoloration. From the meat science perspective, we say discoloration, this brown color. So this browning color produces high retail losses, and you have to reduce the price in order to sell the product. Or you have the other alternative, freeze the product and sold frozen, okay, to get alternatives to sell the product. So this is the characteristic of the bison, even though it's well known that it's a natural, enjoyable product within the red meat group. Okay, so that kind of problem makes me think, okay, what is the problem? What is the reason that we don't have color stability? Okay, why is the reason it's deteriorating so fast, and how we can improve that problem? So today I'm going to discuss a little bit, we're going to do the discussion, the chemistry of the meat color, so we are going to be in the same page. What is the meaning when I use some terminology? What is the possible causes for the pigment oxidation? Okay, and some of the hypotheses drive me to develop the answer project, and hopefully I got it. So and later I'm going to show you recent progress, my research that I started conducting in Agriculture Agri-Food Canada, and give me the foundation to continue with that research using the answer project discovery. And the conclusion. Okay, the chemistry. In order to get the red color, we need a protein, and that protein is Oxy Myoglobin. It's similar as a hemoglobin, okay? That protein, they have 3 redox stages. One is the Oxy Myoglobin is when is binding water, and they have purple color. Usually when you cut the steak, a steak in the middle or muscle, this is the color that you want to see. And later, if you give 20 minutes, it starts the blooming, when the myoglobin bind with oxygen and create the red color. But later, the 3rd stage is when this oxymyoglobin oxidate and become methmyoglobin, that we start seeing the brown color, okay? Those boxes that are here are important, okay? Because when we have high oxygen consumption or very low oxygen pressure, the oxymyoglobin is going to become methmyoglobin. And the other group of enzymes is methmyoglobin reducing activity that transform the methmyoglobin to the oxymyoglobin. Most of you maybe are wondering, why? So if we reduce the pressure of oxygen, why don't change from the oxymyoglobin to the oxymyoglobin? But the problem is, in order to get the oxymyoglobin has to come first methmyoglobin and later the oxymyoglobin. So for that reason, it's very important to handle these 2 elements, methmyoglobin reducing activity and oxygen consumption. If we can manage or reduce the oxygen consumption and increase the methmyoglobin reducing activity, that group of enzymes, we can have a stable red color, okay? This is a picture. So you can see in the middle the oxymyoglobin. In this case, the myoglobin is binding with water. Underneath, or later is the methmyoglobin, or usually the methmyoglobin start forming underneath of the oxymyoglobin. and start creating waves and start showing up when you start seeing the browning. Okay? So we have the myoglobin, and the last layer is the oxy myoglobin, the red color that we see. Okay, there are different factors, intrinsic, extrinsic. Okay, the intrinsic is related with what is the element in the meat. Glycogen storage, that is related also with the pH. Usually when we have higher pH, we have dark color, or it's very low, we can get a pallid color, and so on. Later we can explain in details. But in general, also the other factors, like a pigment concentration, muscle fiber type, myoglobin reducing activity enzymes, oxidative stability. As extrinsic effect, we have pre-harvest and post-harvest. So pre-harvest, we have the diet, the breed, housing, antioxidant supplementation, growth promoter, pre-slaughter handling, sex class. Post-harvest, anything related with the chilling system, temperature, packaging, how we handle the product at the end, okay? But I don't want to spend too much time in that part, just to give you a general knowledge related with the problem. Okay, having this knowledge, the basic knowledge, what is the possible causes of the rapid pigment oxidation? What do you think that would be the first difference when we compare beef with bison from the color perspective? What is the first element that you think that we need to start looking for? Pardon? Fat. Fat. That we are going to talk later. But the first part is the myoglobin per se, the protein. So because the first thought that we have is, no, because there are different species, maybe they're going to have different myoglobin structure. But so far, the study says they have the same amino acid sequence. Also, they have the same rate of the oxidation when it's stimulated or not. Okay? So what is the next step? Okay, no difference in myoglobin. What is the next difference between beef and bison? Fiber type. Bees or bison possess more percentage of the intermediate fiber. Intermediate fiber, they have red with white. Okay, they have both of the extreme muscle type. So in consequence, if we have more red type, muscle fiber type, so we are going to have more pigment concentration. If we have more pigment concentration, we are going to have more iron level in the muscle. And the iron is a pro-oxidant. This pro-oxidant can cause or stimulate the oxidation of the myoglobin. Okay? Are you following me? Sometimes when I give this speech, I feel like I'm in class, no around with some scientists, but don't. Okay. I have the pro-oxidant, okay, based on the muscle fiber type. But the other characteristic that also one of the public mentioned is the fat. Bison usually, regardless of the diet, had more polyunsaturated fatty acid than beef. If we have more polyunsaturated fat, it's easier to oxidate. And we have higher iron level, that is a pro-oxidant. That pro-oxidant stimulates the oxidation of the fat. And that fat can create a primary compounds like a peroxy radical, and the other is 4-hydroxy-2-nonenal. In some studies, especially related with humans, this kind of oxidation or compound from the oxidation of lipid can decrease the electrotransport chain. And this electrotransport chain is very important to supply the NAD that we need for reduction of the myoglobin. Okay? But in bison, we haven't done anything related. So that is part of my hypothesis in my answer, okay, that I would like to find out. This is in general what happened, the oxidation process. It's like who is first, the hens or the eggs? Okay? Here we start the lipid oxidation. We have the peroxy radical, also the HNE. The HNE can react with the myoglobin, and this compound can exacerbate the lipid oxidation. Or the other pathway, the myoglobin per se plus the peroxide can stimulate the oxidation of the lipid and continue exacerbating the oxidation. Okay? But usually most of the research is conducting the lipid oxidation, how the lipid oxidation affect the color. Okay? But what happened with the proteins? It's well known when the protein oxidation occurs, there is a protein aggregation, losing functionality, and so on. So if we are losing functionality, it's good to think like also we are going to lose the functionality related with color. Right? So that protein oxidation can be exacerbated by the polyunsaturated fat based on the pathway that I mentioned before, the heme pigment, transition metal, that is the iron, oxidated enzymes, peroxy radical lipid oxidation, and this compound can react with the protein. Remember that the myoglobin have the iron plus the globin protein. That compound can be affect this globin protein and release the iron. When release the iron, so we are losing the color. Okay? So we don't know now the protein oxidation, what happened in the protein oxidation in bison, and also we don't know how much HNE is produced by bison because they have high level of polyunsaturated, so we need to define or discover if they are producing more HNE. Okay? This is an example of what happened when we have reactive oxygen substrate, how produce the protein oxidation or the aggregation, losing the protein function, the iron, and so on. So this is part of the function that we have. The other element that we don't know is what is the balance of the different proteins that maintain the equilibrium in the sarcoplasm. Okay, this redox system. In beef, we have has been discovered the high level of those compounds or enzymes produce a stable red color. Okay, and also when we have high level of chaperone, contribute to the stabilization of the red color. Okay, so but those studies haven't done in bison. Okay, this is, for example, the chaperone, what is the function? To return, usually when we have the protein oxidation, we have aggregation, and the chaperone helps to return to the normal structure of the protein. Okay, so we have the normal structure of the protein unfold when they start losing the property or start denaturated, the chaperone is activated and return the normal structure of the protein. Okay? This is the possible causes that I would like to find in my answer. But what I have done so far, the recent progress and how the research, what I have discovered in the changes of the intrinsic factor and also especially in the reducing activity. This is the first project. I started doing this project in Agriculture Agri-Food Canada when I was postdoc, and finally we had the final results for this, evaluating the effect of the high electrical stimulation, high voltage electrical stimulation, and the nitride film packaging. We had this idea because we have realized that in bees that is electrically stimulated, is improve the color, okay? Even though the main purpose of electrical stimulation is improve the tenderness, has been discovered that improve the color. Looks like the effect is because the pH go down a little bit and improve the color because they also is produce more lactate, and that lactate help in the respiratory system of the cell. The other element was the packaging. This packaging, they have a nitride embedded on the film. When the nitride film touch the surface of the meat, okay, the juice of the meat or the water in the meat dissolve the nitride. But doesn't mean we are curing, okay? It's just in vacuum condition, we create nitrosyl myoglobin and produce a red color, okay? So we think, okay, we are gonna test the film in bison. Okay, the objective, what is the materials and methods? We have the 480 kilograms bison, in total were 40. Half of the carcass was stimulated in high voltage, the other not, as a control. We monitored the pH and temperature for 48 hours. Also, we did carcass evaluation and grading. And we took samples to evaluate the glucose level in the muscle. Remember that I mentioned to you that is one of the factors. The glucose also sample from the meat to evaluate the reducing activity, oxygen consumption. And also from the longissimus, also from the neck or rhomboides, to create the patties. In that case, we have steak and patties. We overwrap, and also we apply the nitrile film packaging, and we did objective and subjective color evaluation. Okay, what is the result for electrical stimulation? Electrical stimulation could have direct effect on the metabolism of the cell. In that case, the pH was not affected by the electrical stimulation. Okay? Just a little bit here, 3 hours post-mortem after applying the electrical stimulation. But at the end, we have the same level of pH. Okay? We were expecting a pH a little lower or a little low than the control, but we didn't get it. The temperature also didn't change. Okay, when we evaluate the glycolytic metabolites, the only effect was lactate, okay? But that level of lactate was not enough to produce any changes on the pH and also to improve the reducing activity. How you will see also in the color, not any difference in the lightness or bright of the steak, redness, yellowness, chroma is related with the intensive color, and hue related with saturation of the color. The part that I would like to point is what happened with the myoglobin reducing activity and oxygen consumption. Remember, those characteristics are fundamental to have a stable red color, okay? The electrical stimulation didn't affect the metabolism, okay? Just the aging period, when we stored it for a certain period of time, of course, those results have been published previously, okay? But important here, the electrical stimulation per se didn't affect the metabolism. That is also totally different the response that usually have been seen in beef, okay? And also electrical stimulation, they have some limitation depending on the age of the animal, sex, class, other condition, okay? It's not automatically when you apply electrical stimulation, you are going to improve the color or the tenderness on beef. Okay, the nitride. What happened with the nitride? That is the part I fascinated. Because we have here, first, the score given by the panelists, the trained panelists, and we have a triple interaction. A triple interaction involves, of course, the type of packaging, the aging period at 6, 13, 20 days of aging, and involve the days on retail display. Okay? We have triple interaction. Usually, let me explain you to interpret the graph, the score for color going from 1 to 8, where 1 will be pale and 8 will be very dark color, almost browny. Okay? And the surface discoloration, that is in the bottom of the graph here, is related with the percentage of discoloration. It's going from 0 to 100%. Okay? So if you see, at the beginning, the steak from nitrile packaging was considered dark. But in 2 days, when they started reaction with the nitrite, they start changing from dark color to a slightly dark. And later, but in the case of the overwrap, it started like around cherry red color and later become dark color. Surface discoloration, you can see in the case of nitrile packaging, we have low level of less than 20% of discoloration, or the myoglobin formation. In the case of the overwrap, increase almost 80%. That's the same behavior that we can see or performance in the different aging period. Okay? What happened with the hue when we do the objective color evaluation? The hue, remember, is saturation, and how the red color moves in the axis from the red to yellow. Okay? When the number is low, that means that it's more red. So in that case, you can see in the different aging period how has increased the period in the retail display. Start reducing the value, that means is red color. But the overwrap start losing the saturation, the red color. Okay, and so on. You can see this, that behave in the other aging period. In this case, is the accumulation of myoglobin, as expected, start increasing in the overwrap packaging, the level of myoglobin formation. Okay, and in the case of the nitrile packaging, start reducing. Okay, this is a picture, and you can compare the overwrap with the nitrile packaging. I'm going to take the liberty to, whoops. You can see better the picture. Okay? The same behavior that we see in color, in the color score and objective color evaluation, was detected for the gram patty. Okay? The additional information that we have is the lipid oxidation that was higher in overwrap condition than with the nitride filled packaging. Okay? You can see the difference. This red color and this is the browny color. Okay, the next research was related with essential oil. I just started working with essential oil is because my wife started working essential oil in juice. So I said, looks like it would be a good idea to apply the essential oils in meat. So I contact the companies and they provide me the essential oils. I use oregano and rosemary. Everyone already knows that those components have antioxidant properties. So, but we don't know how they work in bison. Having tests in pork and beef, but not in bison. Okay, so I test the product. This was the objective. this is the material method. We obtain 10 strip loin. Those strip loin is from Bison, the grade A1. I can explain you later what is the meaning of that grade. Was aged for 7 days at 4 degrees Celsius. After that 7 days, we process the strip loin. We obtain the initial state as a reference state to compare with the other treatment and to determine what is the initial hemoglobin reducing activity and oxygen consumption before injecting. And later, the strip loin, we split in 3 sections, one for control, one for oregano, and the other for rosemary. So we have 10 strip loin per treatment. So we randomly sort the portion. We inject 0.05 of rosemary and 0.08%. The solution is 0.05, and we inject the 10% of the weight of the portion. We inject the 10%. In the case of the oregano, the concentration in the solution was 0.08%, and we inject again the 10% based on the weight of the portion. Later, we obtain the stakes. We overwrap and put in the retail displays. And at the end of the retail displays, we obtain the stakes, and we do the lipid oxidation. Again, we run the hemoglobin reducing activity and oxygen consumption, how that changed during the retail display. Okay, the first thing that we have in mind, or we are expecting, okay, maybe the oregano and essential oil is going to change the pH. If they change the pH, they are going to change the color. But even though we measure the solution, for example, oregano, in the solution, the pH is 4. And for rosemary, is 6. But was not enough to change the normal range of pH that we can find any portion of meat. Usually, a normal meat, the pH should be between 5.5 to 5.8 of the pH. So we can obtain that kind of range in this project. So the essential oil didn't change the pH. Okay, so pH is not the problem. If you see in the day 0, all of the portion, they have the same pH, and the day 4, they have the same pH as well. The only difference was for the day, but the treatment was equal at the beginning and at the end. So never the essential oil changed the pH of the product. Okay, what is the next result? When we compare the stakes that we take as a reference, what's going on the first day, we compare with the last day, was interesting, the result. Why? Because if you see in oregano, there is a reduction of the oxygen consumption. And we increase the hemoglobin reducing activity. What is the meaning? If we reduce the oxygen consumption and increase the hemoglobin reducing activity, what is the effect? We are going to improve the color. Okay? So that is the first key that we start, it's interesting that result. And when we evaluate the color, in the color score and also discoloration, we can see how the control starts increasing the darkness of in the color, and later followed by the rosemary, and the last is the oregano. Okay? It's red. In the case of the sulfur discoloration, the first one was the oregano, later was the control, and the last, the oregano. The interesting part here I would like to notice is this part. Maybe you will say, hey, but at the beginning you have discoloration. Okay, I would like to clarify, it's not discoloration per se, even though we consider it as a discoloration, was an artifact caused by the injector. Okay? But at the end, as a panelist, we need to determine has a discoloration. Okay? But it was an artifact created by the injector. Okay, in brightness was the same. In the chroma, in the vividness of the color, if you see, in this case, the interpretation of the chroma, when the value start going down, that means we start losing vividness in the color. And the last one in lose the vividness is the oregano. And later, the hue is the saturation of the red color. The meaning is inverse. When we have less value, that means is we have red color. And you see how at the last day, we have red color. The oxidation, you can see the level of oxidation. The oregano has the less level, lesser than the others. The lipid oxidation. Well, the most important that was impact me was this, the color. When you can visualize, okay, wow. The idea when I start working with the color and try to modify the color is not change the natural color of the bison and transforming in beef color, no. Okay, it's just preserve for more period of time the normal bison color. Okay, so you can see here the steak that is from oregano treatment, almost cherry red color instead of the control. You can see that all the surface discoloration, brown in color. So in conclusion, in general, we can see bison meat color stability is a major limitation to the expansion of the fresh meat marketing. The research, the purpose is to discover what other chemical components are related out of the myoglobin effect, are related with oxidation of the myoglobin. So far, we have discovered that in nitride film packaging and utilization of essential oil, good essential oils can be an alternative to improve the color. And the knowledge or the results can be applied at the purveyor level or retail level. Okay? Before finishing, I would like to acknowledge these funding agencies, ALMA and INSER, and especially I would like to recognize the hard work from my graduate students. Thank you so much. Any question? I open.
Okay, very good. Thank you very much. Some questions for Argenis. Yeah, go ahead.
The addition of essential oils will change the taste of the meat?
Okay, that is a good question, and also it's part of the invitation that I show at the beginning to find out is changing the flavor of the product. Okay, I don't have right now preliminary results. We are still running the trial, that section of the trial. Okay, personally, I can detect the oregano, but it's not disgusting. Maybe for some. Yeah, a little bit.
Well, I guess it's a follow-up. Can you just detect a different taste, or can you detect the taste of oregano? Because that can be totally marketed as pre-seasoned. Like I would put oregano on my Italians do it.
Yeah, it's part of the marketing, but so far I need to analyze the data, but so far, personally, when I taste it, I can detect the oregano, okay? But, and also most important of that is I didn't detect personally any of flavor caused by any oxidation, okay? So, any other questions?
Yeah. Go ahead, and then Harry.
Actually, two questions. The first one is, can you describe how you treat the meat with oregano flavor oil, like the treatment?
How I prepare the treatment?
Yes, and the second one is whether trying other antioxidants.
Okay. in order to obtain the treatments, as I mentioned before, I split the same loin. So to avoid any different deposition of the loins of animals, I use the same steel loin. I apply the treatment. Okay. So I have control, oregano, and rosemary. I prepare the solution based on the concentration that I mentioned before, and later I have an injector. I start injecting. When I start determining based on the scale, 10%, that's it. Okay, that is the way. The other question was?
The use of antioxidants.
No, I didn't use commercial antioxidants because right now really we are in the fancy stage like a natural, so I look for that kind of things. And also I limit my using other essential oils because I found in the market just those two that are water soluble. Okay, that was the reason.
Okay.
What exactly is nitrite film? Is it approved for use? Is it the same kind of technology, a nitrite addition to cured meat products?
Okay.
Is it the same idea here?
Okay, sort of, but it's not curing, okay? In that case, again, the nitrite is embedded on the film and only is released when contact the meat, okay? That release is just on the surface, okay? It's not going deeper. After, I'm gonna give you numbers and also part of the experience. Usually, the nitrite content in the film is 130 milligrams per meter square. Okay? When you evaluate the residues in the meat, you are going to find less than 0.7 parts per million. Okay? That was my second research I didn't show. Because part of the idea is, we are adding too much nitrite and we are going to cause cancer, whatever. So the principal thought was, okay, if I can cause me a cancer, at least have to reduce the bacteria. Okay? So I start working with the bacteria and realize like the residue that is in the steak is not enough to reduce the microbiome in the steaks. And in the only way that can you reduce the microorganism, you have to use more than 4 parts per million. And this is not the amount that you can find on the steak. The other difference is the curing color is produced when you submit the matrix with the nitrate to the heat. So you create nitrosyl hemochrome. That is the pink color. But in the case of the this packaging is in vacuum condition. It's for nitrosyl myoglobin. Okay? When you open the package, you lose the color. So just the color is developed in vacuum condition. And also other part of the experience, when I use the nitrite, we cook. So we start evaluating what is the percentage of the steak that develop being cold. Part of the scale, like, we are curing. To be honest, I found just less than 1% of the steak developing pink color.
So is this nitrite film used now commercially?
In US, not in Canada.
Not approved yet?
Not yet. I was not approved. I was talking with, part of the result was used by Cargill and submit Health Canada to get approval, but we couldn't get it.
Yeah. Dr. Paul?
I really enjoy your talk. My background is not animal science. But okay, so my question is that does color change affect nutrition value of meat?
Okay, okay, that's information I don't have by the research per se. according to I heard or reading other papers, especially related with protein oxidation, you can reduce the digestibility of the protein by the human. So also we need to consider as a future purpose of the research, evaluate digestibility if this is possible.
So follow up that question is that the second part of your research, you use the oil to preserve the color. And it's also, you show beautiful data, the injection of oil reduced significantly the oxidant stress, so the T-bars you show. So I'm just curious about, do you have that information on the active components in the oil you use in your study that contribute to the antioxidant effect?
Okay, I have the information given by the company, and also the percentage that I use was based on the recommendation of the company. Okay, so in that case, I didn't incorporate any error. So I use as is recommended by the company. If I have, based on this result, I can change it. But my first try is to use it as is recommended by the company. Okay? The composition is more based on the information provided by the company. They have more phenolic compound. Okay, those phenolic compounds, they have antioxidant properties. These phenolic compounds cover, like, if I'm not wrong with the number, more than 60% of the composition for both oils.
And because we know olive oil is enriched in tyrosol phenolic compounds, and it has a high content of antioxidants. So I'm just curious about the oil you use in your study,
Yeah.
the compounds. So maybe to follow up to your question is that, or previous question about antioxidants. So in the future, if it's too much work to inject oil, maybe we can inject some compounds to the, you identify the major compounds, so you can inject
Yeah,
compounds.
sure. I agree. And also part of the essential oil curiosity, I grow the project for the swine cluster using essential oil. In that case, I will incorporate the oil using based on, as an additive in the feeding. So I still crossing the fingers.
Thank you.
Okay.
Another question? Yeah, go ahead, Anita.
I have two quick questions. One of them, does the color change when you vacuum pack? Is there any difference in terms of just doing a vacuum pack on bison in terms of how that color change occurs?
Okay, when you submit any meat, especially beef and bison, to vacuum condition, okay, but without nitrate film, just a vacuum package, okay, without any additive. It's gonna turn brown at the beginning, and later it's gonna get this a little purple color or dark color, okay? Because in the moment that you remove the oxygen in the package, just in the package you have oxygen residues over there, and this oxygen residue is consumed by the redox system and become dark color. Just when you open, the blooming appear again.
My second question is, how much of this is health in terms of spoilage, and how much of it is just education of people to know that bison meat looks different than beef?
Okay, of course, the purpose is to increase the shelf life, okay, and reduce the spoilage. When I say the spoilage means from the chemical changes, microbiology changes, or physical changes. But usually in mine, we have related spoilage with microorganisms. When I say spoilage, it's related with chemical and related with the color. So my point is to increase at least 1 day more in the shelf.
But is it really not safe, or is it just that it's perceived to be unsafe because of the color?
No, so far in my projects with 5 days in retail display, you can consume without any problem. Okay, based on the the micro evaluation that have done previously, you can consume without any problem. But in other research that have conducted for more long period of time, to be honest, 3 months, just for curiosity, especially with the nitrile filled packaging, you can see in the top, beautiful, red color, bright color, but just open the package and turn it and flip it. Okay, yeah, so it's like the same effect for when you use carbon monoxide that is approved in US and a little bit in Canada. You can masquerade the color and you can consume a spoiled product. But in that case, if you use properly, you can increase on using nitrile filled packaging, you can increase the shelf life without putting risk the consumer for 18 days or 21 days.
Another question? Yeah, Django.
So that's the presentation because olive oil works very well to maintain the color, but actually the rosemary oil didn't work at all. So what do you think the potential reason behind
The potential,
the potential reason?
using any, or I suppose the potential is with oregano, right? The potential is using the oregano because I found the effect. That is, if I understand your question.
No, what is the explanation for the difference between the two, right?
Yeah, because the olive oil so work very well to maintain the color, right?
Okay.
But the rosemary oil didn't work very well.
Okay. The first thing that maybe was the percentage in the solution, the difference. Some other researchers, they are indicating, okay, but you are using different percentage. Yeah, but this is the recommendation from the company. So in this first stage, when you are testing the essential oil, I prefer using as is recommended. Maybe could be the different. Also, maybe, also as you mentioned previously, depend how you extract the essential oil, they are different between companies. This is other detail. The essential oil, each essential oil came from different companies. So on different extraction procedures. Okay, maybe was not efficient in the extraction of the phenolic compound in the rosemary than the other, maybe would be the response for that different. And also to be honest, in other paper, they have had variable response using the rosemary. So I suppose that variation depends on how you do the extraction.
Okay.
In Winnipeg, there's a company by the name of WinPack. You've heard of them. I understand, I went to one of their presentations, I understand that they're fairly large in the packaging industry across North America. And if I understand correctly, they can have, that plastic film can be like 10 different layers or 8 different layers. Some of them are associated with lighting, some antimicrobial, some nitrile. So it's very sophisticated. Are you aware of anyone that ever works with that company to determine where that research will go around packaging and look and see if you...
Yeah, so far, usually I have been working with Venice. This is a company in US. They provide me the film. Okay, but they have in the portfolio different kind with antimicrobial effect.
Yeah,
But
it just seems like they can layer these things and it's still really, really thin.
yeah. I don't know the chemical engineer, but depending on the thickness and the wide of the pores of the plastic, you can create different type, and also using nanotechnology, you can embed the nitrite or any antimicrobial and use it. But I don't know what is the portfolio for the WinPack that they have.
You guys, biosystems engineering might come up. Are you familiar with that company?
No, I heard of it, but I never visited it. I just
Yeah, I was.
by the reputation.
I know Impact. I also was part of the sponsor during the a little seminar that we have 2 years ago about packaging. So I know the company, but I haven't established a relationship with them.
Okay, one more question.
Can I ask a question about how did you measure the color using instrument? Because you extracted L, A, B, chroma, and hue. I just wonder what did you do?
I use the Minolta, okay, the angle 10, D65, the aperture was 4 millimeters. I don't remember that specification, but we use the Minolta.
A spectral photometer.
Yeah. Yeah.
Yeah. So I'm just curious because we do that on garments, on meat, how reproducible is it?
Mm-hmm.
I'll ask you the final question, right? I'm just wondering, in terms of methodology, you inject a substance to a piece of meat. There's no circulation in that piece of meat. How do you actually assure that there is actual distribution or good distribution of the treatment throughout that piece of steak?
Yeah, good question. Okay, usually it's related with the portion, not the steak individually. Okay, so after we inject, we establish 5 minutes the stabilization, and we weigh again and determine the percentage. It's capturing the 10%. If we need to incorporate a little more in order to get the 10% that we establish, we inject again. We stabilize the product, weigh again, to be sure that we are getting the 10% that we say that we are going to inject.
But how does do you inject in one location? And
No, in separate location. Try to be.
Or several needles?
Yeah, several needles in different areas. The only limitation, I need to recognize the limitation because I use a manual injector. So that is a little difficult, but I try to disperse the liquid in different injection areas, okay, and wait. The best scenario, if I have an automatic injector, perfect, you can provide me. So.
Okay, any other burning question? If not, I'd like to present you this little gift on behalf of Dr. Stanley's office.
Thank you so much.
Thank you very much for the very interesting seminar, and to thank all of you for coming.
Perfect, thank you so much.